In NASA, when they launch a rocket, there's a control room full of engineers and scientists ensuring that everything works well. In Atlas, when we have new physics, we have a control room where we also have physicists making sure that everything works well. That's where the excitement is. Let's go to the Atlas control room and see what goes on.
And here we have all the main desk where we can control the operation of Atlas, where we can check if Atlas is actually alive, taking data, if something is breaking or something is not working. Being alive for us means that all the different channels that have to provide data when there is physics can provide this data. I mean, that nothing is switched off, for example. And then we also monitor all the data while we are taking them. Basically, as you know, Atlas is sort of an onion. It is composed by different detectors that have different physical properties. They look at different particles, if you want. So we have different desks for each individual detectors. That are sort of surrounding the main control desk, which are those ones. Those are the desks where we actually control all the, if you want, all the safety aspects of Atlas. Those two desks in here. And this is one of the main desks, the run control desk, where we actually start and stop the data taking operations.
I see behind you some actual pictures, right? Are these
those are real events as we see them online. Of course, we are not now LHC, as you know, is switched off, so those are not events which have been taken at this very moment. Those are events, collision events that we took in the end of 2009 when LHC was working. So basically, this is our event display. It's a sort of a preview of what we are taking, that we're running on real events while we're taking data.
When you're here, you have all these various detectors and parts of the Atlas detector that are running. Do you ask everybody, how are things going? Are you ready to go?
We have shifts which are taken care of by different people. The shift leader is the one that makes sure that we are running as efficiently as possible whenever there is beam.
Now, when I looked at Angels and Demons, there was a sliding glass door with the detector right there.
Indirect injection kicker.
We have a signal on the luminosity monitors. We have events.
Whatever you saw in Angel and Demon happening downstairs is actually happening a bit higher up. But it was a nice imagination, but of course we cannot afford being close to the detector. I mean, the radiation level is too high and it's dangerous, so we cannot really afford being there.
Now, let me ask, back in December, when you got the first collisions, did everything work?
I have to say that it was all amazingly successful. Both the LHC, I mean, the LHC is a very complex machine, and they were able to switch it on without major hiccups in a extremely short time compared to all the accelerator we had in the past. And Atlas was indeed able to take all of the events that were provided to us. We were alive, as I said, alive all the time, and it was a great success, really.
So you say we're going to go to higher energy and also to higher intensity, meaning many more collisions. That must mean we'll be ready to find the Higgs and all the other new physics.
Yes, even though it will take some time, because as you know, I mean, what we're looking for are very rare events, even at the energies that will be produced by LHC. So we know we have to produce a lot of events, a lot of collisions before we actually see some of the interesting events. It's really a statistical process. Plus, you don't have to see just a few of them, you have to see a lot of them to be really sure that what you're seeing is not an artifact of some other standard physics, but is really an evidence of new physics.
So can you predict what we're going to get out of this? What is mankind going to get out of this?
We cannot really predict what is out there, otherwise we wouldn't make experiments. But we can certainly be sure once we see it that we're seeing something that wasn't predicted by the existing model. So it's going to be exciting, yes.
What if we don't see anything?
That would be fantastic as well, in a way. I mean, it's hard to explain to people, but if we don't see anything and we can demonstrate there is actually nothing, it would be equally fantastic from the scientific point of view, because then we need somebody that thinks about all the models to explain all the aspects which are not explained at the moment.
Over the next 20 years, a lot of exciting physics is going to come through the Atlas detector, and it's going to take a team of dedicated physicists working in the control room to ensure that all of the components of the detector work well and that they work together. What are they going to find with these components? That we'll have to see.